Good afternoon, sir. Good
afternoon, sir.
Hold. I'm going to okay. Fine.
So I don't know if it's my side, but you're breaking up coming through.
Breaking up?
Yes, sir.
I'm breaking up.
Hold on. Okay. Please. Anybody?
So repeat that.
So?
You break,
No,
sir.
Still breaking.
I don't know. I'm using. All right. So I'm using I'm going to prospect. When do you hear me?
Nothing, sir. Nothing. We're not hearing.
I'm switching. Are you hearing me clearer on this one?
Yes, sir. A little clearer. Yes, sir. We're hearing clear on that one.
All right. So let me use this one then. Hold on. All right. All right, let me keep this one close by as a just in case. I have to switch. All right. So we were on Maclaren's expansion. I would have sent you some stuff.
Mm-hmm.
How are we feeling? Tonight's class is going to be a lot of hands-on. The truth of the matter is I've already taught you the topic. What is to be done now is for you to do the questions, and then I can guide you through the solutions. So I want to hear from you the challenges that you may.
So which one of the documents you sent? Excuse me, the documents. I don't see that one.
I sent you, did I not send you something from last Wednesday's class? I'm almost sure.
No, sir, I don't see anything, but I
Lord
get...
have mercy. You know, so don't know what happened to me. I prepared a document. I prepared a document. And guess what? No. Prepared a document, but clearly I never sent it. Oh Lord. You sure I never sent it? Yeah, man. Hold on then. I'll check myself.
So you can check. I don't.
Yeah,
I don't see anything in the WhatsApp group. So you respond to Jones, and that's it for that. Nothing else from you.
All right. What's on the group name again? Calculus 2. Calculus 2. Oh, Jesus. I remember I responded to Bijan. I don't even have the document with me right now. All right. I apologize. I did up the document after class, and clearly it was done up, but not emailed. Oh. And hear me saying to myself now that, okay, they're going through the stuff. Oh, come on. What was the topic again? Maclaren's.
You're right, McLaren.
Let me just put it as. My brain is moving faster than my hands. All right, I'm not even seeing them on these files. All right, you know what? Let me not cry over spilled milk. I apologize. In my headspace, I did it. say, look, let me mix up with something. Let me just check something here. If I see it, no, I'm mixing up the thing. All right, move on. What I want to do today with you is to continue with the not Newton ramps. We finished that and see that already. The McLarens, and then towards the end of the class, I really want us to do a little bit of applications to integration, because we would have by then completed the unit 1. I think I get myself confused, and that's what happens when I teach in too many classes. I think I get myself confused. I think I'm confusing myself. All right. I'm confusing myself. Right, because I did show you. This is weird. Yeah, I did show you. Send me never send up something, because this is rare now. Okay, all right. Mystery solved. Let me give you a question, please. Let me give you a question.
You gave us a question to do, so I don't know if it's the same question.
What question is it that I gave you?
Let's see if I can find mine right away. Square over x plus 1.
Okay, here you go. That is where it is. All right. And have you done it? Were you able to do it?
Yes, sir.
All right. Question from the rest of you. Were you able to do that homework, or is just Lotto I gave the homework alone in private class?
Sir, me beg if you can run through this, sir, because me get me confused.
No, but I responded to your stuff, And I don't. You don't even come in and say thank you.
No. And this, so the confusion still continue, man.
Okay. All right. Let me see how much. All right. I will soon look at that one for you. I'll soon look at that one because. All right. I'm going to ask you to do this one for me in the meantime, while I do the solution for that one and send off to you in the WhatsApp, and then we'll have a conversation on that one. So while you are working, I'm going to be working. I would love for you to. I don't want to give you the easy ones, because I know you know how to do those. All right, I have one here for you. All right, I have two here for you. I'm going to do 2 questions with you, plus the homework question, and then we take it from there. This is a past paper question, so let me give it to you. No, I'm not give you that one. If I give you this one, it's not going to cost me. But it's not bad though, it really worked out nicely. Yeah, it really works out nicely. So, and I want one to, okay, it worked out really nicely. All right, let me give you this one. Write this one for me, please. Find the Maclaurin series. Find the Maclaurin series for the function f of x. For the function f of x equal 2x ln 5x plus 1. F of x is equal to 2x ln open bracket 5x plus 1 up to the term x to the fourth. Up to the term x to the fourth. So it reads, find the Maclaurin series for the function f of x equal 2x ln in brackets 5x plus 1, close bracket, up to the term in x to the fourth. Got that?
Think so, sir.
All right, good. Start on that one for me, please. Let me do the solution to this one for you and send it off as WhatsApp. All right, start for me, please.
Wait, what's the term? Maclaurin? Sir.
Yes, crosswords, Maclaurin series.
Oh, Maclaurin's.
Mm-hmm.
Okay.
Sir?
Yes, Mikey.
Sir, how is I supposed to write the function?
I mean, what do you mean by that?
It's a f of x equal 2x ln and open bracket 5x plus 1.
Mm-hmm.
Okay, sir.
What do you recognize that to be?
Sir?
What do you recognize that to be?
Don't think I understand you, sir. Because I thought that the five supposed to be outside of the bracket. So I'm just confirming.
Anybody recognize that to be anything?
Sorry, repeat that, sir.
I'm asking, what do you
That's the
recognize?
rule we are supposed to use. That's what you're asking, sir?
Yes, please.
It don't look like a product rule.
It is a product rule. What's the first term?
2x.
And what's the second term?
The ln extra is this one.
Okay, thank you.
All right. Good evening, everybody. Me again. You know my excitement now. So
What's the problem? What's the problem? Which of the questions are you doing?
this
The two
one
x
is
5x plus 1?
yes, sir.
What about it?
So may I see how all right, we use a product rule, right?
Right?
We use one of the split in a half, so we know 2x are one and the ln part are the next one. So you get 2x times if you differentiate the ln, you get 5 over 5x plus 1. Or me do it wrong.
Very good. So the differential of ln x is 1 over x times the function.
Yeah.
So when you differentiate 5x plus 1, you'll get 5. So it will be 5 over 5x plus 1.
5x plus 1. Beautiful.
Right. But remember, the product rule is the first times the second plus the second times the first.
Yeah. So then you have plus ln 5x plus 1 times 2.
Very good. Very good. And then you're going to do that repeatedly. All right. Good job.
So how may I get rid of Sorry.
Go figure it out. Go figure it out, man. You're on the right track. Continue. Bijan, are you okay now? You follow what I'm saying?
Because may I say, all right, then, if me plug 0 in the ln part, you can use the calculator to get.
Absolutely.
Okay,
Absolutely.
okay, all right.
I am just seeing your question. Can somebody, all right, I think it's f of x, I'm speaking from memory. F of x equals 2x ln 5x plus 1, the 5x plus 1 in parentheses. And
Yes, sir,
right, and I'm going to go up to what? To the 5th or the 4th power?
4th.
We'll go up to the 4th power. Maclaren's, so we can start from it, please, Joe. All right.
Good afternoon, sir. Sorry for being late.
That's all right. What's up?
What are we doing now?
Maclaren's. Write this for me, please. F of x equal 2x ln 5x plus 1. 5x plus 1 in parentheses. Says f of x is equal to 2x ln, open bracket, 5x plus 1, close bracket. I'm going to use the Maclaren series up to the 4th power.
Okay, sir.
Cool.
Wait, it was in the 5th.
Me no know. Them say 4th. Me no remember.
Where's it, sir?
They said 4th, but I don't remember if it's 5th. Let me just check.
A 4th, yeah, this is, sir.
Right, to the 4th power. Yeah, to the 4th power. Possible. Thank you. Can somebody remind me, please? Lotto, the homework question I gave you with 2x over x plus 1, was that to the 4th or to the 5th one?
Let me just double check.
Thank you.
So I stopped at the fourth.
Okay.
One, two, yes, the fourth.
All right, thank you.
What does this look like?
All right, sir. For that one, you just give it, see.
Fifth, sir, fifth. Fourth,
Okay, no problem.
fifth one, sir.
All right, cool. Yes, Bijan, where's the same, Papa?
I get maths error. But me no know. Me do something wrong.
Okay, no. You can't find the logarithm of a negative number. Did you get nobody don't have no negative number substituting. It's zero substituting.
Yeah, zero substituting. So, all right, sir. So the function we get first, right? A 2x bracket 5 over 5x plus 1, close bracket, plus ln 5x plus 1, close bracket, times 2. And then we'll put 0 in our x place them.
Sorry, my head, I was doing a calculation in my headspace first. Sorry. What you got for f of 0?
The function a 0 me get p first.
Okay, fine. Because 2 times 0 is 0. So 0 times anything is 0. So you can have 2 times 0.
Okay, all right.
All right. So when you differentiate the function, when you differentiate 2x times ln 5x minus 5x plus 1, what did you get for the function?
The next function we get is 2x open bracket 5.
Which of the derivative is talking about? The first derivative or the second derivative?
It's the one with the 1 up at top.
The first derivative. Okay. What you got?
You get 2x open bracket 5 over 5x plus 1 close bracket plus ln 5x plus 1 times 2.
Okay. All right, it's the 2x times, what was the first differential again?
2x open bracket 5 over 5x plus 1.
No, that's not what I get for my first differential. No.
So where's so if you have 2x times 1 over 5x plus 1 times 5 plus ln open
absolutely. So you have remember, it's the first times the differential of the second plus the second times the differential of the first.
So so we have the 1 over 5, but we just say because it times 5, we just put the 5 over.
No, you're gonna have 2 separate terms.
So 10, multiply it. I think.
Right. So what you should have for the first differential is 10x over 5x plus 1 plus 2 ln 5x plus 1. Understand?
Hold on there, sir. Hold on there. Hold on there.
You'll multiply the 5 and the 2.
If we differentiate the ln 5x plus 1, we're supposed to get 1 over 5x plus 1 times 5. All right. And you're saying that...
No, but hold on. You remember you have to multiply that by the first term. So it is the first times the differential of the second. So the first is going to be 2x. So it's going to be 2x times
2x.
The differential of ln 5x plus 1. The differential of ln 5x plus 1 is going to be 1 over 5x plus 1 times 5. So you're going to multiply that 2x by 5 to give you 10x. So it's supposed to be 10x over 5x plus 1.
Oh.
And then you're going to have your ln 5x plus 1, and that now is going to be times by the differential of the first term, which is 2.
Okay. I mean, I said this no look right.
Yeah, man. So you have to be careful with the differential because if not, you're going to run into problems.
No, you know, so many have it up at top, but it's just that I never times the 5 by the 2x.
Yeah, man. You have to.
Okay.
Everybody else is okay with the stuff?
So far.
All right, please. Very important, because you see, the problem is, we're slacking off with the differentiation, That is a problem. I know you understand the topic. The topic is not the problem. Where you guys are slacking off, it is with the differential. And that's why I'm not going to give you those polynomial functions to differentiate because I don't know how to differentiate those. It's these logarithmic functions, the product rule, the quotient rule is where you have problems. So continue working. I'm right here. Continue working.
So I know you guys are slack after that bitch, sure. Everybody else.
You're not alone, Papa. Trust me. When the others
Everybody
don't
else are getting it.
No, when the others don't talk, them now understand. I know them. I teach them last semester. That's the general rule. When them now understand, them now talk.
So,
But
sir,
anyway,
for the ln,
Uh-huh.
for the ln 5x plus 1, with the times 2, the 2 can be 2 ln 5x plus 1. You put the 2 up front and make it 2 stay.
No, you're gonna rationalize it, So you're gonna say 2 times 2x times 5, you're gonna give it 10x.
No, not that part, the next part.
Huh?
The next part, right?
We're not talking about that.
Which other part are you talking about? Oh, yeah. So if you multiply that 2 now by ln 5x plus 1, so it's gonna be 2 times ln 5x plus 1.
Okay.
Yeah, man. All right, cool.
So no, sir, everywhere you see X, you must put 0.
Right. In order to get the series now, how do you do your questions though? Lotto, do you complete all the differentiation and then you do the substitution, or you substitute as you go along?
I substitute and write my answer at the end, somewhere on the side. I do
All
everything at once.
Very good. So anywhere in the function, anywhere in the differentials, you see X, you're going to substitute your 0.
Okay, sir.
Very good.
So does my computer have ln?
Say that again?
I was wondering if my calculator have ln.
Yeah, man. Yeah. It's supposed to be submerged and not on the raise key, but it's supposed to be there though. Your calculator, your version.
FX991EX.
Yeah, it's supposed to be in the middle of the calculator. Look in the middle of the calculator if you see. It's supposed to be there. Or look up the top, not the middle, look up the top part. You're supposed to see it up the top part.
Remember? I'm still get material now. Well, Lato.
Where did you get your math error? For which of them? The first differential?
Yes, sir.
All right, let me see if I can.
Yeah. I put the 0 in. We don't know why I get. And Courage late. Courage probably sit down there done. I know. We could do.
I will leave Courage alone enough. All right.
Yes,
All right. So
okay.
Go ahead, Courage.
So actually, I just found out I don't know how to differentiate ln.
Excuse me, Courage.
Whoa, yeah, what is?
Yes,
that is intended to be a joke, right, Courage?
No, sir. I'm so stuck right now.
All right. So the differential of the ln function is going to be 1 over x. So the differential of ln x is 1 over x. The differential of ln x is 1 over x. So when you're differentiating ln 5x plus 1, it's going to be 1 over 5x plus 1, and then you're going to differentiate the term. Yeah, you're going to differentiate it.
Yeah, I get that. This is a product rule function.
Say that again.
We're using the product rule for it, right?
Very good. You're using a product rule, right?
Yeah. Actually, I did it with the product rule. So I'm still confused. I got my answer to
so the product rule is a first, so it's going to be 2x times the differential of the second. So the differential of the second is going to be 1 over 5x plus 1, because the differential of the ln function is 1 over the function. So it's going to be 1 over 5x plus 1.
Times 5.
Times 5. Very good. Times 5.
Plus the differential of the part.
Right. And then now it's going to be plus the second. So you can write back the ln 5x plus 1 times the differential of the first. And the differential of the first is going to be 2x.
2? So what was the question?
The question is 2x ln 5x plus 1, right?
Okay, yeah. Okay. I must have this now.
Sir,
Yes, please.
I mean, say, Lato, I'll probably your calculator.
Yes, I get 0.
You get 0, I get error. So I wonder if we can write error on this.
No, because when I do it, I get 0 too. So that's why I want to find out. I get 0 when I do it.
On my calculator.
Sir, in my brain, I say, long as I see 0 for everything, 0 me write it up. But no, I know for the calculator.
No, I want you to be able to do it properly though.
That more I know to do to sir, because be a 0 be the right. I said the calculator can give me 0.
What are we doing tonight? I'm late.
Yeah, close.
Okay. What are we doing? Thank you for that very potent information. Another question. What
I told you, she did have good evening.
My last.
Yeah, last yet, man. You wait.
My last, and everybody I move on. I'm gonna know what I want.
You wait till I hear the function. Yeah.
And the function is f of x is equal to 2x ln 5x plus 1.
I don't know nothing about ln, so continue.
You know, that's if I come to class early, Miss Allison. You know, Miss Allison, you know, so 45 minutes left in the class?
I know, but when we get to come on from work, sir.
John or Star. All right, come. So write the function down for me. It's f of x equals 2x.
F of x equals 2x.
ln open bracket 5x plus 1 close bracket.
2x ln 5x.
Plus 1.
Plus 1
close bracket.
Wait, I went to open bracket.
Open bracket at the 5x, but after the ln, open bracket. So
okay.
It's f of x equals 2x ln open bracket 5x plus 1 close bracket.
Okay.
This not. Sir, give me one break there. The first derivative, right? Over 5x plus 1 plus 2 ln 5x plus 1. Right? I got differentiate that again.
Yes. Yes.
When I do the plus sign,
Hello. What what rule does it become now when you differentiating?
Well, I'm going to take my time, sir. No.
Can anybody answer that question? What rule does it become now after the first differential?
So it look like a somewhere.
Chain.
Quotient.
Yes, it's a chain rule, but in the chain rule it has two quotient. No, it has a quotient and a product. So it's a chain rule because remember, if you now have linkages, so you have two terms: the 10x over the 5x plus 1 as one term, and then the second term now is going to be 2 ln 5x plus 1.
Yeah.
So you now have the chain rule to contend with.
Hold on.
Chanel, gone silent. You're way too silent, Chanel.
I told you I don't understand. I'm just trying to grasp what we can.
Remember you're on whiteboard for now, answer.
Yeah.
On whiteboard.
I will, you know, but the thing about it is that what I don't want to do is to jump to the board that I want you to be able to try this stuff. So let me ask you, please repeat for me, Vision, your first differential.
Sir, give me 1 second. Let me see if somebody has get it. Like Lato, we will fire it. That teamer make that dream work, you know. So I go like
which one?
The first derivative, you have 10, the first f1 of x, you have 10x over 5x plus 1. And then 5x plus 1.
2 ln 5x plus 1.
Plus 2 ln 5x plus 1.
Yeah. So,
okay.
So we're going to go to the second part, you know.
The second derivative now.
You read
yes,
this
I guess me stuck to me the right this one.
Right.
And I'm saying to you, having completed the first differential, what you're at now is using the chain rule.
Sure, all right.
And the chain rule now.
Oh, hold on, sir. Come and think me confused. All right. If 10x over 5x plus 1, that does look like our quotient rule.
It is. You know,
so we do that quotient part there. When we do that quotient part, you know, then chain part with the next P.
All right, hold on. Hold up. You are going to be doing the chain rule. So the function that you now have, f dash of x, is 10x over 5x plus 1 plus 2 ln 5x plus 1. That's the chain rule.
Yeah.
When you're differentiating the chain rule now, the overarching rule for this question is a chain rule. But in the chain rule, in this particular chain rule, the first term is going to be solved by doing the quotient rule, and the second term will be solved by doing the product rule.
Product, yeah.
So this chain rule, the rule that you must use now to differentiate, to find the second derivative, is the chain rule. But of the two terms that you have in the chain rule, the first term is a quotient, and the second term is a product.
So we treat them piece by piece.
Absolutely. Right, run it for me, please.
So we gotta get maybe 5x plus 1 bracket 10 or differentiate the total. I get 10, and that's where x minus 10x. Differentiate that, and I get 5 close bracket all over 5x plus 1 squared. And if we get rid of some of this, it'll be 5x plus 10 minus. So the 10x and the 5 can times. No. Lato there.
I'm here trying to figure out something.
Right. We try our force or start.
Okay, no. We are trying to get.
Let me get 150x. I wonder if we can do that. Oops.
Sir?
Yes, Courage.
For the second derivative, I ended up at
No, sorry. Which of the derivative? The third?
second.
Oh, for the second derivative. All right, continue.
I'm at 35x minus 10 over 5x plus 1 square plus is in the middle, the chain, plus 2 over 5x plus 1. That's where I stop. I don't know if I'm to do like the denominator. I should add. What did it? Like
All right. So tell me what you got again for the second derivative.
35x minus 10 over 5x plus 1 squared plus 2 over 5x plus 1. I don't know how to continue from there.
I'm a little concerned though. I'm a little concerned that you guys don't remember how to do the differentiation, and it has been a retarded process because I think this is the first time I'm giving you a logarithmic function to work, and they can very well give you a ln function in the stuff. All right, let's go. So when you're differentiating, when you're finding the second term, remember I did say to you that there's a chain rule and you have two terms. So let us do the first part. The denominator, 5x plus 1, times the differentiation of the numerator. What's the differentiation of the numerator? 10. Very good. Minus the numerator, which is 10x minus 10x, times the differentiation of the denominator. What's the differentiation of the denominator?
5.
Very good, 5. All over the denominator squares, which is 5x plus 1 all squared. Agree with that term?
Yes, sir.
Yes, sir.
Okay, so we're finished with the first part of the chain rule. Let us go to the second.
Sir, so we don't have to, all right, we don't have to times fix the bracket. So we're gonna have 5x plus 10. We can do it that way then?
5x plus 10, you can't have 5x plus 10, sir. It's going to be 5x times 10 to give you 50x plus 10. What is wrong?
Hold on, sir. No, man. All right, you see the first part where we fix, we have 5x
no, I see
plus
exactly
1.
what you're talking about. The 10 is going to be distributed over the 5x plus 1. You can't just leave the first term as it is and call it 5x plus 10. It is not 5x plus 10. What you have is 5x plus 1. You know, I'm not surprised that you made that mistake. Remember last week after class, you sent something in the group and I said to you, it is correct, but what was my other part when I said it is correct? Correct, but what? Look back at it and tell me. Anybody can look back in the WhatsApp group and tell me what I said to him. Correct, but something.
All right, some more x.
When you expand, you will get 2x plus 2.
No, man, read the first part.
You said put
the x plus 1 in the parentheses.
You have to put it in parentheses, and Bijan is the same mistake you just made to me a while ago.
Oh,
so clearly,
you mean, okay, Michelle.
Yes,
so we may have
yes,
times the 10, it's supposed to times everything in that bracket.
Yes, Mr. Sir, and that's exactly what I said to you. So that means you don't even respond to my message last week.
No, me not even know where that about, sir. Me not sure. I'm not even know where that about. No, me understand that about. Carry on.
Right. So you have to put it in parentheses. If not, you're only going to be multiplying one of the terms. So the 5x plus 1 must be in parentheses, and all of those are going to be multiplied by 10. They're going to be multiplied by 10. So the rest of you who are making that error, please correct that error from now. You're going to run into difficulties. Let me say this again.
Okay.
Newton-Raphson can come for anywhere between 5 and 10 marks. Maclaren's can come anywhere between 5 and 10 marks. So let us look at it. If they both come for 10 marks each, that's a full question for 20 marks. You don't have the luxury, of giving up those 20 marks. And you know what I believe?
Maclaren theorem this way I do?
Yes, Mom.
So sorry, you tell me this one question would I take up 20 marks?
No, we never said that, sir. We say can come anywhere between 5 and 10 marks. So a question like this, for argument's sake, could be a 10 marker because the function is heavy. And if they gave you a question like this for 10 marks, and they find a Newton-Raphson for 10 marks, that's a 20-mark question, that's a full question.
Wait, sir, say that again. The Maclaren theorem would carry 10 marks?
Yes, miss.
Only?
What do you mean only? Shouldn't leave me alone. 10 marks for a question is a lot of marks.
So much something? I mean, I confuse it with Newton-Raphson. How much is it that normally get for Newton-Raphson?
Anywhere between 5 and 10 marks. The same thing for the Maclarens. And the number of marks is dependent on the function given. If the function is heavy, like this one here, is a 10 marker. If the function is like 2x over x plus 1 that I give you for homework, that's about a 5 marker.
Let me see my mistake and also.
All right. So Courage, you follow what I'm saying now, Courage? Let me go back to you. You follow what I'm saying now, dear?
Yes, I got
so that is just the first piece. Now we need to work with the second piece. The first, which is 2, times the differentiation of the second. Now I'm differentiating ln 5x plus 1 again. So it's going to be 1 over ln plus 5x times 5. Sorry, times 0, because the differential of the first.
Just so you don't put any, so you just write it, you don't put anything beside the first function.
Right, so it's going to be the first, which is 2, times the differentiation of the second, which is 1 over 5x plus 1 times 5, plus the second, which is ln 5x plus 1, times the differentiation of the first, which is 0. The differentiation of a constant is 0. So you see what is happening here now?
So you can
So
for me again, sir.
the first, okay, which of them? The second part of it, of the chain, or the first part of the
Yeah,
chain?
the second, 2 ln.
2 ln 5x plus 1. All right, so let's go. 2 ln 5x plus 1 is going to be the first, which is 2. Agreed?
Yes, sir. Oh,
times the differentiation of the second. Now I'm differentiating ln 5x plus 1.
Okay, okay.
So when I differentiate ln 5x plus 1, I'm going to get 1 over 5x plus 1 times 5. Agree?
Yes, sir.
Right. Plus the second, which is going to be plus ln 5x plus 1 times the differentiation of the first.
Oh, which is 0.
Which is 0. So that third term, ln 5x plus 1 times 0 goes to 0. So what I'm now left with is going to be 2 times 5 is 10. So I'm going to have 10 over 5x plus 1. Not 10x, you know, 10.
Yes, sir, because there's no, yes, 10, because
Right.
it's 2 times 5.
Right. So, so now I have 2 fractions. What I would expect you to do, 2 fractions with almost similar denominator. I'm expecting you now to go and find the LCM. What would be the LCM between 5x squared, 5x plus 1 squared, and 5x plus 1?
5x plus 1.
5x plus 1.
Okay.
Cancel F1.
Remember, you're not factorizing this time. You're finding the lowest common multiple. So you're looking at a multiple of it. You're not looking at a factor of it. So
sir, you don't join them together.
That's what I'm saying to you. I want you to join them. But you said something that I'm trying to correct. Remember, I'm saying to you that whenever you're factorizing, we'll always take out the smaller of the 2. Remember that? When you are finding the lowest common multiple, it means that you're multiplying things. So it's going to be bigger than the other. So it's not going to be 5x plus 1. It's going to be 5x plus 1 all squared. That's your denominator. Your denominator is going to be 5x plus 1 all squared. I don't like your differentiation tonight, class. The differentiation tonight is not where I want it to be.
What is it? I thought we just get that alien something like that. All right.
Okay.
So the final answer for the second derivative, I got 85x plus 20 over 5x plus 1 squared. Sir?
85x.
Yeah, I want to correct you. Show me how come over.
85x. Work with me, courage. Work with me. So, so 5x plus 1 times 10 is going to be 50x plus 50. Agreed?
50x plus. So where are you?
Sorry, 50x plus 10. Good. Minus 10x times 5 is going to be minus 50x, don't?
Yes, sir.
All
over the
all over the 5x plus 1 all square. So we have 10 over 5x plus 1 all square done.
Oh,
yes, sir.
And then we're going to have plus 10 over 5x plus 1 to the first.
Yeah.
All right. So take it from there now, Courage, because I shouldn't get 85. So take it from there for me now.
I found a mistake. Where the 10 and 5, I did addition instead of multiple. I was getting
okay, got you.
All right. Me not sure myself. So, sir, yes, sir. Yes. 5x plus 1 squared as the denominator, right?
Yes, sir.
And when you put that as the denominator, so you add everything up at top. Or you work out everything up at top.
We're going to work with everything up at top.
Because
before you go any further, though, tell me what you have up at top.
Sir, all right, when we put the denominator as 5x plus 1 squared, we get 50x plus 10 minus 50x plus 10.
No. You're going to have 50x plus 10 minus 50x done over the 5x plus 1 all squared. That is the first term. And then for the second, you're going to have a plus sign separating the two. Then you're going to have 10 over 5x plus 1.
No, man, me have that part there already, you know.
No, but you said no, sir. Let me tell you what you said a while ago.
No,
you said 50x plus 10 minus 50x plus 10.
All right, sir. Me have that part that we just said a while ago. How me move from there?
Finding the LCM now. So do you have two terms, Bijan? Simplify it for me first, Papa. The 50x will cancel out with the 50x. So you're going to have 10 over 5x plus 1 all square.
Plus,
you get that?
Yes, sir. You see that?
Plus 10 over 5x plus 1.
You see that P? Okay.
All right, good. You find the LCM now. Remember, the LCM is lowest common multiple. So you're going to look to see which of them is bigger, technically. So it's going to be 5x plus 1 all square. Then you say to yourself, how many times 5x plus 1 all square goes into 5x plus 1 all square? You say 1 time. And 1 time.
Go back with that, sir, again. How much time can 5x plus 1?
5x plus 1 square go into 5x plus 1 square. And it's 1 time. And 1 times the numerator, which is 10x, is going to be, sorry, which is 10, is just going to be 10. All right, do me a favor, guys. Do me a favor. You see, if you don't do it like this, when you're finding the third differential, it is going to make it, if you don't combine it to get a single term, your third differential is going to be way off. Way off. And you know, it's not by chance I give you an ln function tonight. You know? Not by chance I give you an ln function. Last year, Calculus 1 paper, there was an ln function on it. I don't know if I'm going to take up the same question and give you this year. Or another ln function. And I don't know what, and the ln function is not a problem because you know how to differentiate the ln function now. What I'm seeing is the combination of those two functions now to give you a single function is what is turning out to be the issue. And I don't want to say anything because you guys need to figure it out. All right, do me a favor. We're going to scrap the algebraic one for now. Just get a clean page and just write this for me, please. So 1 over 2. 1 over 2 plus 1 over 4. 1 over 2 plus 1 over 4. What's the LCM?
We draw one line, sir. Remember, so we use the
draw. Sir.
Wait, you say 1 over 2 plus
4, sir.
All right, very good. The answer is the LCM is 4. Why did you not use 2?
2. 4 can't go in a 2.
Can't go in a 2.
Yeah.
2 can what?
4 can't go in a 2.
Cannot go in.
Okay, four can go in a 2. All right, good. You see what it is that we do now? So you understand the concrete version. But the abstract version, no, when we're talking about the algebraic fractions is where you have a problem, because that's exactly what they say now. So I'm saying to you now, so 5x plus 1 all square, cannot go into, 5x plus 1 cannot go into the other one like that. Just like when you said 2, the 4 can't go into the 2. It's the same concept we're talking about here with the 5x plus 1 and the 5x plus 1 all square. All right, so so yeah, man, it's the same thing, you know.
All right,
So
sir.
that's why we give you these fractional stuff from little school, you know, so that we can build on it. All right, don't move because we don't finish the question yet. Do for me now. So now that you have the LCM as 4, can you combine those two fractions for me and tell me what your final answer is? Don't use a calculator.
Sure, you're gonna say 2 into that goes 2 times. You write the 2 up. So 2, 1, and you write it up on the line.
Very good. Very good.
4 into that goes 1. You carry the 1 up and times it by the top, the numerator. 1.
And you can get how much? 1. And then you can do what with the 2 and the 1?
You add them.
Yeah. And we have again
4.
Very good.
But
so why don't you transfer that knowledge now into the algebraic functions?
Sure. Oh, we're going to say, we've been drawing like
it's the same thing, you know.
Me not look on this, I know that, sir. Right now, me had everything. One. Oh, you're going to say that, you know.
And that is do. And I know all of you know how to add those two fractions, a half plus a quarter. And if you get a 3/4 and it don't make no sense, we can deduce it. You have half a cake, and then you get a quarter more of the cake. You have 3/4 of the cake. So we know the 3/4 is the correct answer. What I want you to do now for me is to transfer that knowledge of 1/2 plus 3 plus 1/4 to get your 3/4 with this algebraic function now. Go ahead for me, please. May I give you 5 minutes to figure it out and tell me what your final answer is.
I can't wait to see this answer. It goes 1 time. 10 plus is going to be 2 times. Hey, 2 10s are 20, that's all. So, yeah. 30 over 5x plus 1. Weird. Boy. What's that? There? When you say, yeah, wait for this, I sit here, but this is stress you out. Oh, me did for say this with you. So we need to ask, what point or what we call it now? What you use to say, all right, then that we use for write.
That question is for me, Bijan?
Yes, sir. May I ask you, like, at what point of the equation you realize, right then? We will draw a line and do that.
When you have two fractions separated by, with a negative sign or a positive sign, you can combine them.
If they have the same or a similar denominator.
Them not have to have the similar denominator, because the 2 and the 4 are similar.
Oh, yeah. Okay.
You know, I'm not pleased tonight at all. I'm not pleased. We're forgetting some fundamental stuff in mathematics, and it's cause for concern. Cause for concern. Cause for concern.
So I'm not cause for concern, sir. Yeah. Well, for me, I don't know. You see, because a while I know do something, I'm not gonna remember if we use all them things that we learned from high school back in them excitement. Yeah. So if we see if you, well, how me learn, you give you an example and you go through it. I'm gonna sit right, I need to put in that in it. You give me 2 more, I'm gonna do them, then me get the graph. So it worked for me. Me not gonna remember all of them, sir. May I be honest to you.
Yeah, but fair enough, Jean, but you see the thing about it now, son, is when I give you so a team member calling me, but I'll answer him afterwards. You see the thing about it now is, let me tell you where I have my concern. I can teach you the topic like I have done. I don't know what function the
exam people then will put on the paper.
Yes. And then they're going there and going to make a mess of something. And it's not that you don't know how to do something.
No,
you don't know how to do something. So that's where I have my concern, because I know how to do something, but because of whatever it is, and we're going there and make a mess of the question and get 0 out of whatever amount of marks the question value. And that is my concern.
We're not going to do that, sir. We're not.
Vision,
don't put words in a sermon. Make sir speak.
Another first thing I teach a course, and I see it happen over. Case in point.
Somehow,
you remember
repeated anyway. So
you remember me saying something, Vision, and say, when you're doing the something, always put it in parentheses. You read it and never know when me I talk about, and you never say something to me, so could I explain it? And the same error that you made last week, Wednesday, I picked up on that error. I picked up on that error tonight, and I'm saying to myself, and this is why I keep saying, ask the students from Calculus 1, when students don't speak in class, I'm not talking about you, Jean, because you're active in class. When students don't speak in class, and for me to have an idea as to what is going on in their head spaces, it poses quite a bit of problems. Because now it is that I don't know where you are, and you may leave and say, yes, I understand, but what you understand is nothing.
Sir, we reply in a group, sir.
We never see it.
We put our function in a group and I answer say if it should be this, and you're busy at work, so we try. Yeah.
No, man, which we're talking about. Did I not respond to you?
Because you said the parentheses one. I'm saying, should it be this? I said no function, and no, I come after that.
Hold on there. I clearly missed that second part of the.
Me take a beating, sir, but I just look at practice.
No, man, no, because
so you missed that one, or you missed my own.
Yeah, man, I just look at practice.
Oh yes, no, you're talking truth. I missed. Yeah, it's true. It's true because I just seen your stuff no Lotto. Yeah, I see your message Lotto. I see that. Should it be okay? So I did miss your. Okay, all right. Let me give me the function, please, guys. I know it's 5 minutes, but give me the function.
The original one that you did.
F of x equal 2x ln.
2x ln.
5x plus 1.
5x plus 1.
Open bracket 5x plus 1.
And it should be in terms of 4.
So f dash of x is going to be equal to the first times the differentiation of the second.
Times 1 over 5 over x plus 1.
Times 5 plus the second.
Second is 2x ln 2.
Times 2. So that gives me 10x over 5x plus 1 plus 2 ln 5x plus 1. Agreed right there?
Yes, sir.
F of 0 is going to be anywhere in the function I see x, I put 0. 0 over 1 plus 2 ln 1. But ln 1 is 0, don't?
Yes, ln1 is 0.
Right. So this is going to be equal to 0. That's going to be equal to 0. Then now f double dash. F double dash of x is going to be equals to this chain here, the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator
Times 5.
all over the denominator square. That's that part. Then now the second part of the chain is going to be this first. So you see this chain rule has two rules, quotient and product. The second part of the chain now is going to be the first times the differentiation of the second. 1 over 5x plus 1 times 5 plus the second plus ln 5x plus 1 times the differentiation of the first, 0. So all of this goes to 0. So what I'm left with now is 5 times 5x, 10 times 5x is going to be 50x. I'm going to have 50x plus 10 minus 50x all over
5x1, 5x1.
all squared plus 5 times 2 is 10 over 5x plus 1. All right. Now, this now is going to give me, when I simplify this, 50x cancels this 50x. So I'm left with 10 over 5x plus 1 all square.
Minus.
No, plus.
A plus? No, no, true, the focus on the 50x.
So that is going to be my second differential. That's going to be my second differential. All right, now let's go. F triple dash. No, sorry. I'm going to combine those.
So just as I remember the fractions with that.
Yeah, I'm going to combine those. So when I look at this,
and that mean that bueno, sir.
No. It's just that it's all right.
Sir, meaning, don't get me wrong. Meaning,
no, man. I get what you say, man. You're saying that you saw the thing like that, but you see, yeah, but you see, if you do it like this, it's going to be, if you don't combine it, Papa, you're going to have tons of problems. You're going to have too many large terms dealing with.
Okay.
Yeah, man. So you want to simplify the function first, always.
All right.
I think somebody asked that question in one of the classes recently. Always simplify before you start differentiating, because if you don't simplify, your differentiation will get out of hand. All right, let's go. So I'm going to have 10 over 5x plus 1 all square plus 10 over 5x plus 1. LCM is 5x plus 1 all square. 5x plus 1 all square into 5x plus 1 all square goes 1 time. 1 times this 10 is going to be 10. Plus, watch me. How many times can this go into this? Your answer is going to be 5x plus 1 time.
Answer.
Go ahead.
Oh.
Oh, okay.
Okay.
And if you look at it, look here, look at it. Look at where I'm drawing my stuff. Can you pick up from here now the 10 over 5x plus 1 square? Can you pick up that term from this? 10 over 5x plus 1 square. Can you pick it up?
Yes, sir.
All right. Look for this term. 10 over 5x plus 1 is going to be this. But you have 10 5x plus 1 over 5x plus 1 square. But you recognize that the 5x plus 1 can cancel into one of these, don't?
Yes.
So that's going to end up with 10 over 5x plus 1, which is what you have right here. All right? Which is what you have right there. Which is what you have right there. So you follow me?
You know what I see when we do like this.
All right, no.
Sir,
So,
you know mind all of this, sir.
Uh-huh.
Let me get that part there, you see. Me I say a 5x plus 1 squared and 5x plus 1 in a 5x plus 1 squared, not good.
No. Watch me. And you're not alone. You're
That's
not
what I was
alone.
thinking as well.
I know, that's why I say you're not alone.
So explain that, please, sir.
You're not alone. And that's what one of the things I like about you is that you speak up. 5x plus 1 squared into 5x plus 1 is the same thing as 5x plus 1 times 5x plus 1 over 5x plus 1. This is what I just did a while ago. I break up this 5x plus 1 squared into those two. This cancels it. I am left with 5x plus 1. You follow that now?
All right.
You see that, Lotto?
Yes, sir. I'm seeing that.
Yeah. So again, I'm going to say to you, students, there are students in this class right now that a while ago I had to look to see if some students are in class. You have not even cleared your throats. Not even cleared your throats. My lovely student came in at 6:13 and said that she's leaving at 6:46.
I wonder who's that?
All right? 6:13 and left at 6:46, and you don't understand the topic, and you're gone.
Wait, this is 6:13, sir?
It can't. No, it's all right. Don't worry about it. It can't be right. But anyhow.
So we're going to once we get that, we're going to go on to the third differentiation.
Right. So this is going to be 10 plus 50x plus 10 over 50x. Yeah. Over, where am I? 5x plus 1 all square. And this now is going to be 50x plus 20 over 5x plus 1 all square. So this here now is my second differential. That's what I'm going to differentiate now in order to get my other term. I'm going to pause here because I recognize that you have a class. One of two things. Do you want me to continue working the question? I mean, you go to class, but me continue working the question and then send it off to you tonight? Or you want to finish the question on your own?
Sir, well, for me don't want you to finish the question.
All right. So I'm gonna ask you all to log out now to go to your other class. I don't want you guys to be. Everybody have a class after this? No?
Sure. Yes, sir.
Yes, sir.
All right,
Project management.
Go to your class. Go to your class. Go to your class. I will continue enjoying myself doing the question by myself.
Sir, no, sir. Me not going away, sir.
Oh, you don't have a class?
No, sir.
Okay.
You don't have a class?
No, I don't have a
class.
If you don't have a class, you can stay with me. But if you have a class, please, I don't want you to be late for your class. I will send off this PDF document as soon as I finish the question. All right? So if you have a class, please log out now and go to your class.
Sir?
Yes, please.
Sir, the last couple of class, when can we get the recordings for them?
All right, I need to ask you something. I was able to send the recordings by clicking on I don't even know if I should even say it no. Anyhow, I was able to send the recordings from my phone, but every time I click on it, it is giving me an error item, an error button on it. I don't even know if me explaining this is even making any sense. So I recognize that there's only one device that I can send it from, that I don't always have that device from. If anybody can, computer students can help me out there. When I'm trying to, normally when I'm uploading the recordings, I upload the recordings from my cell phone to the YouTube channel.
That is not working out. I think you can just share it
all of a sudden,
in Google Drive. If it's not uploading.
In Google Drive? No, I'm going to tell you why. I need to find out, that's why I'm asking to find another way, because you see, when I do that, all right, let me find another way, because I am trying to cover myself in terms of the posting dates, because I would have had some unfortunate experiences in the past where things are said that things were not sent in the Google Drive, or things were not emailed, or things were not WhatsApp. I want, when I have control over the YouTube recordings and the post date of those recordings, I'm actually covering myself. So allow me to find another method to get it done up. It's all right, I'll find another method. I have to cover myself, because I mean, some students are not genuine in how they report matters. And I have been victim of it way too often, as recent as, never mind, way too often.
Because sometimes
I'll find another way, all right?
Because you see, sometimes,
but Mikey,
class,
Mikey,
yes, sir?
Mikey,
yes, sir?
Mikey,
yes, sir?
Remember I said to you, I keep saying to you, whether or not I upload this recording, I would have taught calculus to a gazillion times. All of those recordings are in the YouTube channel. And I'm saying, if you are really using the stuff how it is supposed to be used, I've said this over and over again, look through the channel, find calculus 2, the topics are labeled. Clarence, this, that are labeled.
Okay, sir. I'll use that method then. I'll use that method.
Yes, man. Keep saying, anybody ever hear me say that in class before, or maybe them gone already? But I've said it over and over. Yeah, man, go and look at this. You have, matter of fact, if I don't post one more recording in something, I'm gonna still have the recordings here, because I'd have taught calculus to a gazillion times. Well, since COVID, when I created the YouTube channel, that is, right? And it's there. But anyhow, let me finish up this question. So this is 50x plus 20, 50x plus 20. 50x plus 20, this is f double dash of x, is equal to 50x plus 20 over 5x plus 1 all squared. Let me just double check. 50x plus 20 over 5x plus 1 all squared. All right, right. So I'm differentiating that one now. No, talk truth, Lotto, Jean, and I see Mike is still here. Tajay, you're from Tajay through Wola class. Tony, me not hear from you either. But anyhow, you're so easy, that it's so nice that function looks. Just two terms, upper and lower. So I'm going to differentiate this now. So I'm applying the quotient rule. Yes, man. So f triple dash of x is going to be equal to the denominator. 5.
No, that is 0 in another one there. I already do it after.
It's 0.
Oh, sorry. I never did it. I never did a 0. Thank you.
Oh, the 20.
Yes. So f double dash of 0 is going to be equal to 20 because 50 times 0 is 0 and 0 plus 20 is 20. 5 times 0 is 0, but 1 squared is 1. So we have 20 over 1, which is 20.
Yes.
And f dash of 0 is equal to 0.
Yeah.
And then f of 0 is equal to 0.
0 you get.
Yeah. And see, because these are what I want, let me highlight this.
And if
all right, let's go. Thanks for that reminder. Let's go. So it's a denominator times the differentiation of the numerator. Uh-oh, the differentiation of the numerator is only 50, don't?
Yeah, yes, sir.
Minus the numerator. Bijan, look at what sir doing. I am putting it into parentheses.
Yeah.
So minus the numerator times the differentiation of the denominator. So it's 2 times 5x plus 1 to the first times 5. All over the denominator square. 5x plus 1 all square. So f triple dash of x is equal to 50 times 5x plus 1 all square minus 2 times 5 10. So this is 10 times 50x plus 20 times 5x plus 1. Talk truth.
Oh.
So you don't square back the square again.
The square.
5x plus 1.
I don't finish that. I don't finish with that yet. It's a numerator I was asking you to look at.
Oh, okay.
So do you agree with that? It becomes 5x plus 1 to the 4th?
Let me see.
Yes, sir.
All right.
Hold on, sir. Let me process that then. Because we that rule. All right. 1, 7.
5 to 10.
May we point you, Bijan, to tell me, say, all right?
Yeah, yes, sir.
All right, good. And the rest of you that are here, okay too?
Yes, sir, I'm okay.
All right, good. So now, look at what look at what teachers are going to be saying now. I am going to be factoring out.
Yeah.
So that means I'm looking for the smaller of the two terms. Watch me. F triple dash of x is going to be equal to 10 is common, but I'm not interested in the 10 now. So we can just do this and say, I'm going to do this and say 5x plus 1. I'm not interested in the 10 just says, and I'm going to show you why. This is 50 times 5x plus 1 minus 10 times 50x plus 20. Hold on. All over 5x plus 1 to the 4th. All right, look at what I did. I look to see what is common here, that is common there. You notice 5x plus 1 is common. But sir, the 10 is common to the 50. Yeah, I agree. But that's not going to help me now because I'm going to find f of 0. So, sorry, f triple dash of 0. So it's not going to help me there. So I'm going to leave it as it is. What I need to do is to factor out this 5x plus 1. So look at what is going to happen now. Look at what is going to happen. This 5x plus 1 cancels there and cancels and leaves 3 of those. All right? And then I'm going to have f triple dash of x is going to be equal to 50 times 5x is 250x plus 50 minus 250x minus 200, talk truth,
Right.
over 5x plus 1 cube. So work with me.
We cancel
50 times 5 is 250. And of course, the x is right there. So I get 250x. 50 times 1 is going to be 50. Minus 10 times 50x is minus. And that's supposed to be minus 500. Where do I get 50 from?
10 times 60 how much? 500.
10 times 50.
It's minus 500x. And 10 times 20 is 200. Follow me?
All right, sir.
All right. So what I now have is f triple dash of x is going to be equal to 250 minus 500 is going to be minus 250x.
Yeah.
Minus 150 because 50 plus 50 minus 200 is minus 150 all over 5x plus 1 all cubed.
Okay.
Tell me if you're all right, you know.
Okay. Yeah, sir. Let me see that. Yeah.
And then this is going to give me negative 150. Look at that and tell me if you see why I get a negative 150.
Yes, sir. Good.
Because this will be 0. 250 and then that.
Go again.
Remember, negative 250 times 0 is going to be 0.
Oh, you put in a 0. That is sir. What is Jappy this year already? Come on now, Richardson.
The rest of you all right? Talk to me. I'm pausing here just to find out if you're all right.
Sir, wait, me all right.
No, man, I'm gonna send it. Don't write, man. I'm gonna send you this document as a PDF.
Sir, me have to write,
yeah, me know you all right, but I want to see what I go on, man. I want to see what I go on first. So me get negative 250x minus 150 over 5x plus 1 all cube, and then now my f triple dash of 0 is going to be negative 150. All right? Then how much we're going to again? May I go to
4.
To the 4. So may I have one more for the then?
Yes, sir.
All right. Work with me now.
Right.
So recall f triple dash of x is equal to, where do you go again? Negative 250x minus 150 over 5
plus 1 cube.
To the cube, thank you. All right, so now let us go through the differentiation one more time. Last time, f to the 4th of x is the denominator times the differentiation of the numerator times negative 250. Talk truth. Yeah? No?
Yes, sir.
Minus the numerator. Watch me. Minus the numerator, negative 250x minus 150. Minus the numerator times the differentiation of the denominator times 3 times 5x plus 1 squared times 5. All over the denominator square, which is 5x plus 1 to the 6th power. So, Bijan, I'm not killing your method, you know. But it's when I sing my song and I do my stuff. I know
remember, yeah, I teach, I know, sir.
I do, as I said before, I used to use your method, but I find this one so much easier. Let us go again, just for your purpose, because I know you were taught that method and you're stuck with it.
No,
Let's
sir,
go.
me kind of all right with that one here.
You kind of get it? All right, one more time for the road. So you have a function. It's a denominator. When you call it, you write it back. Times the differentiation of the numerator, which is that. When I differentiate a constant, I get 0. I'm differentiating negative 250x, I'm going to get negative 250 right there. Minus the numerator, all of this is negative 250x minus 150, see it right here. So always enclose them in
Yes,
parentheses.
sir. Yes, sir. I forgot again.
Times, which is the multiplication sign here, the differentiation of the denominator. This 3 comes in front here, so I reduce this by 1, so it becomes second, but remember, I have to differentiate inside here. The differential of that is 5. All over the denominator squares. Remember, when you're squaring it, the power is the times it, so it's going to be 5x plus 1 to the 6th power. If I see that on paper, but you make a mistake somewhere else, you do get a mark for this differentiation. The differentiation ends right here incidentally. What is left is for me to just do some algebra. So let us do some algebra now. F to the 4th of x is going to be equal to, wow, negative 250 times 5x plus 1 to the 3rd. Minus 3 times 5 is 15. This times this is that. This 15 times this negative 1 is negative 15 times negative 250x minus 150 times 5x plus 1 to the 2nd power. Or
fast, man. Where you going to do? Where you going to sir?
All right. So what I said.
Just your times it. All right, go on, continue. I'm seeing.
Right. You see it now.
Yeah.
Everybody see it?
Yes, sir.
Yes, sir.
All right, good. Let us continue now. So I am looking here to see what is common. Already, I'm seeing that 5x squared and my 5x to the 3rd. I'm factorizing, so I'm going to take out the smaller of the two. So I'm taking out 5x squared, 5x plus 1 all squared. So I'm going to have f to the 4th of x is equal to, I'm taking it out. But sir, there's something else that is common because 15 is common to, 5 is common to, is common to the 250. I'm not interested in that just yet because I'm going to expand after. So I'm going to take out that. What is left now is going to be negative 250 times only one of the 5x plus 1 because I took out 2 of them. Talk truth.
Right.
Yeah. Minus 15 times negative 250 x minus 150. And I've already taken out all of this 5x plus 1 squared, so there's nothing more to come out. And that is all over 5x plus 1 to the 6th power. So let me go again and show you what it is that was done. I am looking to see what is common. 5x plus 1 cubed, 5x plus 1 squared. I'm factorizing. So when you factor, it's always a smaller one that you're talking about. When you find the multiple, it is always a bigger one. 2 is a factor of 4, but 4 is a multiple of 2. 5 is a factor of 10, but 10 is a multiple of 5. So the factor is a smaller, the multiple is a bigger. All right? So what we're doing here now, I'm going to factor out the smaller. So I'm going to take out all of the 5x plus 1 all squared. See it here, so? And then what is left? This 250 is left. See it right here, so? I'm taking out the 2 of these from this. That means we have 1 left. See it right here, so I don't have to write to the first power. Then I'm going to write my minus 15. See it right here, so? I'm going to write back my negative 250x minus 150. See it right here, so? I'm not writing back this because that is already taken out right here. No, what I'm going to say is that cancels into that and leave 4 of them. And then now my f to the 4th of x is going to be equals to negative 250 times 5 is how much? That's 1250.
Yes, sir. Negative 250. Yeah. 1250.
I'm correct? Negative 1250?
Yes, sir. Yes, sir.
All right, let me show you how I did that quickly. I know 4 times 250 is 1,000. I know 4 times 250 is 1,000. And then I just add 1 more 250 to it to get the 1250, right? So you just have to go use the mathematics in ways that you sometimes you can't read. Anyway, I'm not going to show up on the
teach, I know, sir.
What is 15 times 250?
Plus
3,750.
Sir, I see a method them use a while ago and do that to the sir. They're bright too.
Yeah, man, the teacher, when the teacher teaches, the student's supposed to be brighter than the teacher. All right, so 15 times 250 is going to be 3,750. And 15 times 15 is 225. So that's going to be 225 with a 0. Talk truth.
Yes.
So it's positive.
Right.
Yes.
All over 5x plus 1 raised to the 4th power. Wow. F to the 4th of x is equal to 1250 plus 3750 looks like 2,500 to me.
No, that's it. Yeah, 2,500.
Right. And this look like plus 2,000 to me.
Right, sure. Bright spots.
All right. And then now, f to the 4th of 0.
Yeah.
Okay, equals to 2,000. But sir, if me go to the exam, sir, I do a question like that, I see me reach 2,000, sir, me stop coming to the question wrong. Just do something now.
Sir, you have a point card. There's some feel. Me can't get zeros when we get we are 2,000. Me do
man, just do the question, man. You're on the right track. When no one is supposed to do, just do the question. All right. So now Maclaren's expansion now speaks of watch me. F of x is going to be equals to f of 0 plus f dash of x over f dash of 0.
What is last started?
Over 1 factorial times x plus f double dash of 0 over 2 factorial times x squared plus f triple dash of 0 over 3 factorial times x cubed plus f to the 4th of 0 over 4 factorial times x to the 4th plus ... I'm not going any further because I asked him to up to x to the 4th. So how easily I was able to write it? Let's go. F of 0 is the same thing as f of 0 over 0 factorial times 0, x to the 0, because anything raised to the power 0 is 1. So I can just write f of 0. But for the first one, it's f dash of 0. You notice everything here says 1. F to the 1 of 0, x to the 1 factorial, plus f double dash square 2 factorial, f triple dash 3 factorial, x cubed, f to the 4th of 0, 4 factorial, x to the 4th. And I can tell you the 5th one is going to be f to the 5th of 0 over 5 factorial, x to the 5th. I can tell you the 100th one is going to be x to the 100 of 0 over 100 factorial,
100 factorial, x to the 100.
Yeah, man. So now, your calculators are supposed to be in place, in hand. I don't have mine in. Oh, I can reach mine. So it says, oh Lord. Oh, I need to do something first. Recall, what am I recalling? F of 0, f dash of 0.
0. Yeah, 0, 0, 20. And
F dash of 0 is also equal to 0. F double dash of 0 is how much?
0. F double dash is equal to 20.
20, and the next one is 3 is
negative 150.
Oh, yes.
Negative 150.
And f to the 4th dash is 2,000.
Yeah.
Agreed?
Yes, sir.
All right. So I'm recalling these as
minus.
So look at what I'm doing.
Sir, do me one favor there, sir. We want to f of 3, what we do it? Okay, all right.
So f of 0 is 0. That is 0. F that is 0. So the first one is going to be f double dash of 0. So look here. This is 0. That is, you know what? Let me do it this way. So f of x is going to be equals to 0 plus 0 plus 20 x squared over 2 factorial
plus
minus 150 x cubed over 3 factorial plus 2000 x to the 4th over 4 factorial. And I expect that this one going to be, since that's a 0, I'm going to start with a plus, then a minus, then a plus. I expect that going to be minus. I can put minus dot, dot, dot. All right? And then now, my f of x is going to be equal to, what is 2 factorial is 2. 10 divided by 2, 20 divided by 2 is 10. So this becomes 10x squared. 150 divided by 3 factorial.
We're going
to get 25 x cubed. 2000 divided by 4 factorial. Whoa. We're going to get 250 over 3 x to the 4th. Lie. Minus. It's not supposed to be plus. That's supposed to be minus. And that's my answer.
So me not get to, me get to bracket something.
What? I guess so.
Let me do it. 2000 times 4 factorial.
We get the 3 by 3.
I'm sorry?
I get 250. I get 250 over 3. So use it as the fraction.
As a fraction.
Oh, everybody get that.
Yeah.
2000 divided by 4 factorial.
Okay.
Oh, you say it here.
Now to my next class.
Sir?
Sir, check your WhatsApp. I'm going to run to my next class.
All right, no problem. All the best, man. I will do that for you.
All right.
Sir, I'm leaving.
Somebody saying something?
Yes, sir. I was saying I'm leaving for the next class.
All right, yeah, man. All the best.
Sir.
Yes, Papa.
We put in the 2000 divided by 4 factorial. Me get 83.33. Oh, let me fix that.
And all right, look on your calculator to see if you say S to D or F to D.
On the button part or
on the raise button. On the raise button, you should say F to D or S to D.
no, it's not the raise button. No, it's not the raise button.
Nothing?
Another ABC button.
No, it's not the ABC. Which calculator is in again? Tell me the name again.
This Casio FX28 MS.
Look above the 9 or above the 7. Look where you see the 7, 8, 9. Look above that line, the line immediately above that to see if you see F to D or S to D.
7, 8, 9. Look above that line. Let's say SE. Is it RCL English? And cosine.
Take a picture and drop it in the group now. I mean, look on it.
No. All right, sir. Take it.
All right, I'm looking. All right, press shift. The shift is up top. Press shift and then press the ABC. Keep the number on the calculator. The same 83.333. Press shift, then ABC.
Oh, okay. Okay. All right.
You see the 250 now?
Yeah.
All right, cool.
All right. That's right.
Go back to get the stuff. You get the WhatsApp with the notes? Bijan? Oh, he left?
Go again, sir.
Oh, now I thought he left. Now I was saying, you see the WhatsApp? Check your WhatsApp.
Okay, yeah, we'll see the.
You see the notes? Yeah, man. Go and work on that. Just look it over. When you finish, look over the stuff. Then I will send another question in a group so they can work on that for tomorrow.
Yeah, all right, this out, sir.
Please, yeah, man. And I agree with you. So when you write it out now, just try and understand every step you write, and any step that you write and you don't understand, highlight that step so I can explain it for you.
So when I will write it like 2-3 times. You know.
Very good, Pops. Very good. All right. All right. Enjoy. Have a good one.
All right.
Cool. Take care.